In this video, we're going to take a step back from the contacts activity just for a moment and implement in its entirety an infrastructure component that's going to be necessary for implementing the contacts activity, as well as the rest of the activities that we're going to be working with in this application. Basically, what I want to do is I want to write a scheduler class, a class that's able to schedule operations to happen. And the reason I want to do this is for a variety of reasons, actually. Let's say that you want to have a piece of code ran every X milliseconds. Or let's say that you want a piece of code to run when the activity that got an event was resumed. So let's say an activity gets paused, it receives a service response, and then it gets resumed, and you only want your code to execute after it got resumed. So we need to be able to queue up events. So yeah, basically that's what it's going to do. And I'm going to do this inside of its own class because I want to add this scheduler to our base fragment and our base dialog fragment and our base activity so that it's available throughout our entire application. So let's go ahead and get started. In the infrastructure package, I'm going to right click, select new Java class, and I'm going to create an action scheduler. Now, the first thing I'm going to do here is I'm just going to stub him out, just like usual, so you guys can get an idea of how this class is going to be used. So I'm just going to write all of his methods real fast. So he's going to have a constructor that's going to take in an application object, first of all. Then he's going to have a onPause method and an onResume method. So these methods are really important because they'll affect the behavior of the action scheduler. Because, for example, let's say you have a timed callback that you want your activity to do something every X seconds, but your activity gets paused. You'll want to go ahead and you'll want to pause that timed callback and then resume it when the activity gets resumed. So it's important that the action scheduler gets notified when the activity or the fragment that it's attached to is paused or resumed. Next up, we're going to have a method, an interesting method, very useful method, invoke on resume, and it's going to take a class CLS, or we can do CLS, and runnable. So what's going on here? So our invoke on resume method is simply responsible for queuing up and runnable to be invoked when the activity or a fragment has been resumed. Now, the interesting parameter here, though, is this class. Why are we accepting a class parameter? Well, basically, again, this method will be used for, let's say, your inbox. You're in your inbox activity, right? And you send a request to receive all of your new messages. And then let's say that before that request has a chance to come back, the user opens up a new activity on top of your inbox activity. So your inbox activity gets paused. Now let's say that that request resumes and gets sent to the inbox activity before the inbox activity gets resumed. So the inbox activity is paused, right? But then it gets that service response. So what should it do? Well, the solution I came up with is to avoid running code in our service response handlers when the app activity is paused, which will typically result in an error. I want to queue those handlers to be invoked on resume, which is what this method is for. This class CLS is going to be used to filter out different invocations on resume. So let's say that 5 service responses of the same type come into the inbox activity while it's paused. What I want to have happen there is I want only the last one to be processed. So that's why this method takes in a class parameter. It's used to kind of think about it as collapsing the callback on a particular class. In this case, the class will typically be the response type of the service call. Okay, so that's our invoke on resume. Now let's go ahead and do our post delayed method, which will take a runnable, and a long milliseconds. So that's pretty straightforward. This runnable will be executed after X milliseconds. Now we have interesting things. So now we'll have an invoke every milliseconds, which will take a runnable, and a long milliseconds. So invoke that runnable every X milliseconds. And we'll also have a invoke every milliseconds overload that'll take a runnable long milliseconds Boolean run immediately. So this run immediately additional parameter just specifies, should we run the runnable that was passed in right now in addition to scheduling it to be ran every X milliseconds. Okay, then what I want to do is I want to create two specializations of invoke every milliseconds. I want to create a post every milliseconds. So we're going to go ahead and say object request long milliseconds. What does this do? This will just post an object on the bus every milliseconds. And then we'll have a post every milliseconds object request long milliseconds Boolean post immediately. So you use these methods, the post every milliseconds, to send a web service request or a service request every milliseconds. And so it's just a convenience method to the invoke every milliseconds, really. Now, the last thing we're going to need is a private class. And I'm going to create a private class of timed callback that implements runnable. And because it implements runnable, we'll have to put our keyboard cursor on the red squigglies and hit Alt-Enter, Enter, Enter to implement the run method. And we're also going to have a public void schedule method. And we'll also have a constructor, so I'm kind of doing this backwards here, sorry, of runnable, and long delay. So that is what our timed callback will look like. So yeah, so that's just a really quick outline of what this class is going to be capable of. All these methods are going to be really straightforward, and they're basically all going to rely around a handler and our paused and resumed methods. So let's just go scroll all the way back up to the top, now that hopefully what this class does is a little bit more apparent, and let's just fill out each member one by one. So I'm going to start off with my private fields. So we're going to have a private final your application. We're going to have a private final handler, and we'll call this handler. Now the handler is what's going to be used to actually do the delay. So if you recall, we used a handler as well in our base in-memory service, and we used it to invoke a runnable after a particular delay. And that's what we're going to be doing here. We're going to be using it to invoke things on delay. Then I'm going to create a private final array list of timed callbacks, and I'll call these timed callbacks. Then I'm going to create a private final hash map of class and runnable. Now these are our onResume actions. And the final thing is we need a private Boolean to keep track of whether or not we're paused. So we'll have a private Boolean is paused. Now ignore all those red squigglies because they'll go away once we implement our constructor. They're just telling us that we've marked these fields as final and we haven't assigned them anything in the constructor, which is an error in Java because final means that the values can only be assigned in their constructor. So we'll start off by saying application equals application, handler equals new handler. So far, nothing too interesting. This dot application equals application. Thank you, IntelliJ, for that. Timed callbacks equals new array list. See, I really do prefer prefixing private fields with underscores, but we're in Java and when in Rome and all that stuff. Next up, onResume actions equals new hash map. And we'll say is paused as... Well, it doesn't really matter, actually, the way things work, so I won't initialize is paused. Next up, we'll implement our isOnPause method. OnPause will simply say isPaused equals true, so we can keep track of when we're paused. Now, I want to point out, the onPause method isn't being invoked anywhere. The way that this class is meant to be used is the activity will... On the activities onPause method, he will invoke the action scheduler's onPause method. All right, now let's do our onResume. So in here, we're going to say isPaused is false for the first thing. Then what we're going to do is we're going to loop through all of our timed callbacks, and we're going to tell them to reschedule themselves. So I'm going to say for timed callback in timed callbacks, callback.schedule. So what we're doing is we're simply looping through all of our timed callbacks, and we're telling them to reschedule themselves to be invoked in X milliseconds. Next up, I'm going to say for runnable in onResumeActions, runnable.run, or whoops, it'll be onResumeActions.values, because it's a hash map. And the final thing is onResumeActions.clear. So we're looping through all of the actions that we've queued up to be ran on resume, and then we're clearing them all out after we've run all of them. All right, so let's do our invoke on resume. Pretty straightforward method. I'm going to say if not is pause. So if we are currently running, then simply do runnable.run and early exit out. So if we're not paused and invoke on resume is invoked, then we just invoke the thing because we're not paused. So yeah, pretty straightforward. But if we are paused, then I'm going to say on resume actions, dot put CLS runnable. Now, this is really cool. So I'm doing the .put CLS runnable, and what that's going to do is if more invocations are put into our invoke on resume of the same type, the latest value will override the previous value. So that's why I'm using a dictionary here, or a dictionary. Again, my C# is showing. That's why we're using a hash map here. All right, so now post delayed. In post delayed, pretty straightforward. We're going to simply say timed callbacks. Timed callbacks handler. Handler. I'm getting really mixed up here. Post delayed, passing in runnable milliseconds. So we're just deferring to our handler. Pretty straightforward. Our invoke every milliseconds. This one is just going to defer to his other overload. So we're going to say invoke every milliseconds, passing in runnable milliseconds, and then true. So the default behavior of invoke every milliseconds will immediately invoke the runnable that's passed in, and then schedule it to be ran more times in the future. Now for our invoke every milliseconds, I'm going to say timed callback equals new timed callback, passing in the runnable as the runnable, the milliseconds as the delay. Then what I'm going to do is I'm going to add it to my timed callbacks. And then I'm going to say if run immediately, if run immediately, timed callbacks dot run, or sorry, runnable dot. So if we're on run immediately, then timed callback or callback. Wow, how am I managing to fail this miserably? Dot run. Otherwise, then we want to go ahead and post delay it. Or post delay it. So to do that, we're going to say post delay timed callback or callback milliseconds. So if our run immediately is set to true, then we immediately run it. Otherwise, we post delay it. So we invoke that callback after X milliseconds. Now let's do our post every milliseconds. Like before, we're going to post every milliseconds, but we're going to base it off the other post every milliseconds. And we're simply going to use the overload to provide a default value, which will be true to post immediately. And then for our post every milliseconds, we're going to defer into invoke every milliseconds, passing in a new instantiation of a runnable. And the runnable will simply say application get bus post request. And then for our second parameter will be milliseconds, and then finally post immediately. Now, the only thing that's interesting about this method is when I typed in request and hit enter, the parameter up here was marked as final automatically. That's because we're accessing it from within a closure, and the final modifier is required. All right, so that's it for our action scheduler. Let's jump into our timed callback. So our timed callback is going to have two private fields. He's going to have a private final runnable, and a private final long delay. Then we're going to say this dot runnable equals runnable. Oh, come on. Runnable. And this dot delay equals delay. His run method is simply going to say if is paused, return. So if the activity was paused when this runnable was told to run, then simply exit and don't run itself. Otherwise, do runnable. Oh, come on. Runnable dot run. So otherwise invoke the internal runnable and then reschedule himself. So run the thing that's supposed to be ran and then reschedule himself. And for the last method, we simply have to invoke or do schedule, which is simply going to be timed, or sorry, our handler dot post delayed, passing in this as the runnable and delay as the delay. And that's it. That is our awesome action scheduler.java. So the final thing that we have to do here is we have to integrate our action scheduler into our fragments, our dialogues, and our activities so that we can take advantage of all of this timing functionality in other parts of our code. And it's going to be really, really important for things like our inbox and other things that you want to refresh on a particular interval. It's also, like I said, incredibly important so that to have this invoke on resume method. Because otherwise, a service call, a response of a service call might come in while the activity is paused, which could do very bad things. I want to point out that it is possible to use a feature called produce or producers in the auto event bus to accomplish a similar thing, but I'm not too much of a fan of that because of the additional complexity that it throws in and the additional amount of code that you would have to write to handle that. For some things, that feature is perfectly valid. For others, it isn't. And in this particular case, I chose to implement this logic this way instead of using auto's produce method. Anyway, so let's go ahead and integrate this into our activities. So let's jump into activity. Let's jump into base activity. And for our base activity, I'm going to create a protected value. I'm going to say protected action scheduler. Then on our onCreate method, after we get our bus and alias our bus out, I'm going to say scheduler equals new action scheduler, passing in application as its only constructor argument. So once I've instantiated the scheduler, that's pretty much all I need to do, except for there is one thing. In fact, no, I'm not going to, well, I will go ahead and do it. I will go ahead and create a getter for it. So I'll say public action scheduler, get scheduler, return scheduler, just in case we need it in the future. All right, so that's my base activity. That's the only change I had to, or I almost forgot. We have to, on our base activity, we actually have to tell our scheduler when we are resumed and when we're paused. So let's scroll down to our on resume and on pause methods, which we haven't implemented yet. So let's go ahead and override those. I'm going to say override public void on, or protected void on resume, super on resume, and then scheduler dot on resume. Override protected void on pause, super on pause, scheduler on pause. Now let's do the same thing to our fragment. So let's open up our base fragment. And up here at the top, I'm going to create a protected scheduler, or action scheduler, derp, scheduler. On create, I'll instantiate him after I alias out my application. So I'll say action scheduler equals application. And then I'll go ahead and create my on pause and on resume. So I'm going to do override. In this case, they'll be public. So on pause, we'll simply invoke scheduler on pause, and as well as super on pause. It's very super important that you remember that. And we'll do our override public void on resume, which will do super on resume and scheduler on resume. And that's it for our base fragment. So now let's do the same thing to our dialog real fast. So let's go into our base dialog fragment, and he will have a protected action scheduler, and he's going to have an override public void on pause. This is tedious. Super on pause and scheduler on pause, and override public void on resume. Super on resume, scheduler on resume. And that's it. So basically all we did was we created a new class and we instantiated it in our base dialog fragment, in our base fragment, and in our base activity. And we did the same thing in all three cases. But now what we have is we have an awesome action scheduler that we can use to do all sorts of different things. And if we ever add new functionality to our action scheduler, that functionality will be available to all of our fragments and all of our activities. So you can kind of see that we're kind of creating this sort of pseudo application framework as we're moving forward to really bring some order into dealing with Android's interestingness in some regards. Anyway, I think that's just about it for this video. Just a quick detour from our contacts activity. So in the next video, we'll go ahead and start back up on that.